All right, now for the third and final segment for machines. Left off, talked about the six simple machines a little bit in detail, how we talked about the wedge, the screw, and the inclined plane, how they are similar. Looked at how the wheel and axle and the lever are very similar, and obviously pulley, which is wheel and axle and a rope. So how they're all kind of related to each other. One of the things we talk about with machines, though, is mechanical advantage, and it's how much, basically, it's how much is a machine helping you. Look at this. It's the ratio of how much a machine changes your force. So it's output force divided by input force. And most machines, 99% of the machines are going to have a mechanical advantage of over one. So we tried to simplify it a little bit and say, if you're talking about forces, which are obviously some kind of newtons, take the bigger one and divide by the smaller one. And it usually tells you the mechanical advantage, because you wouldn't use a machine if it didn't make the work easier, or the amount of force that you get out of it easier. So mechanical advantages is almost always a number that's greater than one. And whatever you're because it's giving you more force output than what you're getting into it, it's almost always a trade-off with, if I'm getting a bigger force or more force, it's going to have to change the distance that I did. So I'm going to usually have to do something for a greater distance. If you look at this person as she pulls down, it's then going to lift this load or this rock or whatever that thing is. It's going to lift it up, but it's going to lift it up a smaller distance up than she has to move it down. So there's always that trade-off, but it is make it easier than lifting it straight up. Sometimes it's a matter of just changing the direction. It's easier to push down than it is to pull something up against gravity. Pulleys are notorious for that by the fact that I can pull the rope down and make the object go up, pulling down, I can use my weight to help me, which then makes work easier. What we talked about earlier, though, is the amount of work will never be less. Okay. In fact, most of the time you're going to do more work when using a machine, because there's a small amount of friction, even in simple machines. The more complex the machine, the more friction there's going to be, and the less efficient it's going to be. I know the formatting on this came out when I switched it from PowerPoint to Google Slides is a little bit different. But basically what it's saying is the work output divided by the work input, as we see down here. And then we multiply it by 100 to get an efficiency and a percentage. But the work output and the work input is really what you're looking at. So you're looking for things like joules. And this is number, because it has moving parts and a little bit of friction, will never be more than one. You want a number to be less than one, because no machine can be 100% efficient. So the more simple machines you add up into it, the less efficient it's going to become. But a lot of times, the more mechanical advantage that you could have when you get into these compound machines. Gears we didn't really focus on. In pulleys, we look at the number of rope segments that are lifting up on the machine or on the object in order to figure out its mechanical advantage. The difference with these, what make them, is you're going to have to travel a longer distance. You're going to have to pull down farther on the rope than the object's going to move up. And that's kind of a recurring theme with machines. And that's basically the end. The things that you'll have to do is mechanical advantages, efficiency, and know the machines themselves and what they do. Don't forget to look at the videos that we have on there, the handouts. We got full PowerPoints on there of a bunch of different stuff. So any questions, feel free to email. Thanks, and we'll see you next week.